Distance time graphs are a lot easier to read if you can remember that, one, these are not maps of the motion, they are models of the motion. So if you look at these graphs, you can see two things when you have a distance time graph. You can see the position of the object at any given time just by reading the graph. And you can find the speed or velocity at any given time just by finding the slope. As an example, to find the position, where will this object be at 75 seconds? Well, all you have to do is go over 75 seconds and up to approximately 25 meters. So you know at 75 seconds, it will be 25 meters away. You can also do the opposite. How long will it take an object to go, say, 30, or let's even say, well, we can't do 40 because we don't have the graph. Let's say 30 meters. How long will it take to go 30 meters? So you go over to 30, and you see that it would take 100 seconds to get to 30 meters. The other part, the speed or velocity of the object, is used by finding the slope of the line. So we can just remember that speed or velocity is equal to the slope. Now I'm going to start using the term velocity because you can tell the direction of the object along with the speed. So for this object, what is the speed just by looking at the graph? Well, you find the slope and you use the slope equation that we all know. We know that this is 100, 30, and this coordinate is 0, 10. We just use our slope equation and we say y2, which is 30 minus 10 minus y1 divided by x2, which is 100 minus 0. And so we get 20 divided by 100. Now it's helpful to remember that these numbers actually have meaning. So this is actually 20 meters and this is 100 seconds. And so we find that our slope is 20 meters per 100 seconds, or 0.2 meters per second. And that is our velocity of this object throughout this straight line. Now, another example, we have a negative line, a negative slope. This is going to mean that our object is moving backwards. And we can show that because if we find our slope, so this is 150, 100, and this one is 0, 200. So we take y2 minus y1, or 100 meters minus y1, which is 200 meters, divided by 150 seconds, x1, or x2, minus 0 seconds. And we find out that we get negative 100 meters divided by 150 seconds. And so our slope is 0.666 negative. Let's call it 0.67 meters per second. That means that this thing is moving in a negative direction or backwards. This line, think about it, where is the object at 25 seconds? Well, it's about 12 meters away. Where is it at 75 seconds? It's still at 12 meters away. It hasn't moved. So the speed is going to be 0. We can confirm it because a flat line has a slope of 0. It is moving at 0 meters per second. That's just the slope of a flat line. That is the speed of it, because the slope of a distance time graph is the speed or velocity. Now this last one is broken up into bits. You can find the average speed by finding the initial and the final and finding out the average speed, but you can see the speed changes throughout. At this point, it has a positive slope. It's moving forward. You can find the speed by finding the slope. It'll be a positive number. During this time interval between 10 and 15 seconds, the slope is 0. It's not moving. And then what happens here, you have a negative slope between 15 and 20 seconds. The object is moving backwards.